All right, so I'm going to solve this exercise again, 2023 Fall Midterm 1, question 812. I solved it in the classroom, but more than one student came and said that it wasn't clear. So I'm going to try to explain it again and actually give an option as well as an alternative way of solving it. So we have 14 cheerleaders. They have to be seated around a circular table. And Becky must be across Melissa. Amber must sit across Ellie. And they want to know how many ways can I accomplish this, right? So let's just recall let me just take this out. So let's recall the concept of circular permutation. Let's say that I have 5 people and I need to sit them on a table. So for this chair here, I have 5 options, or you can think about this. This first person has 5 options of chairs. Then the second one is four options of chairs. Then 3, then 2, then 1, right? However, we talked about this in the class. Let's say that the person number 1 chose, so person number 1 chose, so this is person number 1, 2, 3, 4, 5. Person number 1 chose that chair, this chair, and that. So this is one possible configuration. If we rotate, meaning that the person 5 goes to the left and goes to person's 1 seat, everyone goes to the left, it is still the same, right? So this is 1 step left. Or you could give 2 steps left, okay? And 2 steps left would mean that 5 here goes furthermore 1 to the left, okay? And so if this person 5 jumps to 1, jumps to 2, jumps to the chair where it's 3, jumps to the chair where it's 4, in the 5th iteration, it goes back to the same place, right? So this rotation, 1 to the left, then 1 more to the left, then 1 more to the left, and 1 more to the left, this 5 configurations are the same. So, and that's where it came the formula, right? So we would have 5 times 4 times 3 times 2 times 1, but all of these options are they have to be divided by 5 because 5 options are actually collapsed into 1, okay? And then you have 5 then 5 canceled. This is 4 factorial, where the formula comes in n minus 1 factorial, okay? Cool. Another way to interpret the circular permutation that makes the formula work as well is having a person seat first, okay? So I have the 5 chairs, right? And I will choose a person to sit first. So I'm going to choose person 5, for example, to sit here. After I set this person first, I kind of break the symmetry because remember, to be a circular permutation, I have to have a symmetry. And then I can continue with the normal permutation. So when I choose person 5 to sit here, I have like one choice, only one choice, right? Because, so person, not 5, sorry. Let me take person 1, because I started here at 1. I was looking at the circle. So I choose person 1, okay, to sit here. So actually, my person 1 must decide where to sit okay? And he can't have 5 choices. She will have only 1 choice, okay? Then the second person have 4. Then the second person has 3, then 2, then 1. And you can see that this is the same formula. It's n minus 1 factorial. So this reasoning of sitting one person first holds, right? So you sit one person you can interpret the n minus 1 factorial not only with the rotations. You can interpret it in a different way. You can interpret like take one first, sit them down. As soon as you do that, you don't have these rotations anymore because there's no circle anymore. The symmetry is broken. And then you continue with the permutation, okay? So this was the way I solved the problem. So what I did was I had 14 cheerleaders. So I had 14 cheerleaders, and what I did was I took one of them and sit them first. So I took A, which are my constraints, and usually we always start by the constraints, okay? So I sit A first, and it is as if A, the first cheerleader, doesn't have 14 options. It just have one, the seat that I decided to her, right? It's here. Then, because I have a constraint, Ellie will sit across. So again, I don't have a choice. Ellie doesn't have a choice. She can't choose. Then I will, again, solving the constraints first, I'm going to ask Becky to choose. Well, Becky now, and again, I broke the symmetry with positioning A first, right? So now it's just a normal permutation. So how many options Becky has? Well, Becky has 1, 2, 3, 4. Well, it has 12, right? 14 minus the 2 seats taken by A and E. Well, but if Becky sat there, Melissa, will necessarily, she won't be able to choose. Necessarily, she won't be able to choose. So that's 1. And after that, I will ask the other girls. So then the other one will have 10, meaning I have 10 different chairs to choose, minus the ones occupied by the 4 girls, and up until 1. So this is 12 times 10 factorial, okay? So during the class, I used the fact that I set someone first in the first place, okay? Which is a modification of how to interpret the n minus 1 formula, and it works, okay? Now here's an alternative way to solve this. So let's, because we have a constraint, let's sit, oh, well, it's already drawn there. So let's sit all of my constraints, and I can do that. Like I say, okay, guys, because you have constraints, can you please sit in your positions? So A, E, B, M are taken, okay? Now, sorry about that. Let me put here. All right. So if I do that, the other girls, like the next girl that I asked choose a chair, she will have 10 options, okay? So if I do this, I have 10 factorial, okay, options. All right, but this is one setup to seat, okay? I can change the setup by flipping, where is it? Okay, so this is 10 factorial. And now let's flip, let me copy this, and we can flip the same seats, but we can flip the people. Like here is Ellie, here is A, here is M, here is B, right? Just flipped, okay? But I could also flip again. I could flip, and I'm gonna do this entirely. So I could do, I could do A, AE and MB. And finally, I could do EA and BM, okay? So we have 4 chairs permutating, like the four constraints permutating. And I have 4 options here, okay? I have 4 options. So in the end of the day, for this configuration, I have 10 factorial plus 10 factorial plus 10 factorial plus 10 factorial. So for each configuration, I have 10 factorial, meaning that I have 4 times 10 factorial, okay? Cool. So now, how many configurations can I sit down these girls, okay? So you can think about this. Let me copy again. So I can't, so you can see that the AE pair is jumping two seats from BM, right? So you have 2 available seats. One other option would be sit. So this is the first option. The second option would be to sit. So A here, E is to sit B and M is to sit. I'm not going to paint it. A B and M 1 seat across, right? So you have just 1 seat across. And the other option is to have B and M sitting beside, okay? Right? So I have 3 configurations. The other configurations are accounted for in the 4 little specifications. So for example, this BM could be MB, and inside the calculation for this, the 4 different configurations, this will be accounted for. So in the end of the day, so I have, this is not 10 factorial, this is 3 configurations. Each of these 3 configurations will have 4 times 10 factorial arrangements, okay? So in the end of the day, the answer is 12 times 10 factorial. It's the same. So 2 ways of thinking, because we break the symmetry, right? By having the constraints of people sitting across one another. It's easier to think this way, sitting first a person, okay? While other exercises is easier to think of this way. For example, the exercise where you have 5 people glued together. So you have a where is it? You have 5 people glued together, right? And they're kind of a blob of people, a mutant or whatever. And you have actually only 10 things to permutate, or 10 options. The symmetry isn't broken when you do that. So you can kind of use the formula directly of n minus 1 factorial, okay? You could think about, well, sit this blob of people first. You can do that. And it will do this, it will be the same thing. Okay? So there are two ways to kind of think of it, right? So I hope it's more clear now what we've done. There are two ways of thinking. This one's more complicated, I guess, of finding the configurations. This one here is better, I guess, this one here, because it uses this thing about sit one person first, okay? And it's a way of thinking about n minus 1 factorial. So sit someone first, so that person doesn't have choices, it's just one, and then you continue with the permutations, okay?